Neptune, the farthest and most mysterious planet in our solar system, has always been an enigma for astronomers. But what lies beneath its cold, silent exterior? Recent discoveries hint at something far more astonishing than we could have imagined. Newly obtained images of Neptune have revealed details that could alter our understanding of this distant planet. Whirling storms, hidden cloud shadows, gigantic geysers, and colossal vortices create a picture of a dynamic and ever-changing world that lives its own life, invisible to the naked eye. What exactly is happening on the surface of Neptune, and what forces drive these enormous storms? But the most intriguing aspect is Neptune's moon, which may harbor an entire subsurface ocean beneath its icy crust. Could this ocean, hidden on the coldest moon in the solar system, contain life? What other secrets does this enigmatic world hold, and is science ready to uncover them? Recent images of Neptune, taken with modern telescopes, have caused a sensation in the scientific community. These images are the clearest ever captured of the most distant planet in the solar system. Previously, after the Voyager 2 mission, scientists believed they had a sufficient understanding of the planet's appearance and atmospheric characteristics. However, recent data have disproved previous assumptions, revealing that Neptune is a far more complex and mysterious object than previously thought. NASA released one of the latest photographs of Neptune taken by the Voyager 2 probe, an active spacecraft launched by NASA on August 20, 1977, as part of the Voyager program to study the outer planets of the solar system. The image was captured on August 25, 1989, but was only made public 35 years later. Voyager 2 took these images almost exactly 12 years after its launch from Earth. After visiting Jupiter in 1979, Saturn in 1981, and Uranus in 1985, Voyager approached Neptune on August 25, 1989. During its flyby, it also visited 2 of Neptune's moons and discovered new moons and rings. Neptune is located about 30 times farther from the Sun than Earth. As a result, it receives very little sunlight, making it challenging to obtain high-quality images. In this context, the Voyager 2 spacecraft had to use long exposure times to photograph the planet. The images captured during the mission were transmitted as radio signals using 13-watt transmitters. It took about 4 hours for the signal to reach NASA's network of radio antennas, covering the distance from the spacecraft to Earth within the solar system. Neptune became the last stop for Voyager 2 before it headed towards the edge of the solar system. But what else does this mysterious planet conceal? Could it be that studying deeper layers of Neptune's atmosphere will unveil even more astonishing phenomena? Neptune has long attracted scientists' attention with its powerful storms, which burst forth like bright flashes of anger into the tranquility of its deep atmosphere. One of the most astonishing discoveries was the Great Dark Spot, a giant storm roughly the size of Earth that moves across the planet's surface. This atmospheric phenomenon resembles Jupiter's Great Red Spot. However, there are significant differences between them. Unlike the long-lived storm on Jupiter, which has been observed for hundreds of years, storms on Neptune appear to be more transient and unpredictable. Surrounding the spot, wind speeds reached supersonic levels of 2,400 kilometers per h, making it the highest measurement in the entire solar system. The Great Dark Spot was first discovered by the Voyager 2 spacecraft in 1989. However, later observations with the Hubble Space Telescope revealed that this storm had vanished by 1994, surprising scientists. The disappearance of such a massive atmospheric formation indicates the extreme dynamism of weather conditions on Neptune. Subsequently, new observations recorded other storms with characteristics similar to the Great Dark Spot. But each also proved to be short-lived, disappearing within a few years of formation. Storms on Neptune are not just temporary weather anomalies. They are characterized by incredible wind speeds of up to 2,100 kilometers per h, making Neptune the windiest planet in the solar system. These extreme winds not only create gigantic vortices, but also unusual atmospheric structures, such as long cloud bands that stretch for thousands of kilometers along the planet's equator. The dynamism of such processes compels scientists to rethink their views on atmospheric phenomena in the remote corners of the solar system. The well-known astrophysicist and science communicator Neil deGrasse Tyson has repeatedly emphasized that space is full of mysteries that we are only beginning to understand. Neptune is yet another example of how profound and unexpected discoveries in the solar system can be. So why do storms not occur all the time? Scientists have uncovered a secret ingredient that creates atmospheric storms on the outer planets of the solar system. They believe the cause lies in the fact that methane, after hydrogen and helium, is the most abundant gas in the deep layers of the atmospheres of ice giants. Although methane usually just circulates in the atmosphere, modeling has shown that under certain conditions, this simple hydrocarbon can significantly alter heat transfer within the planets. In the upper layers of the atmosphere, methane can condense, forming droplets that then descend into lower layers. In these lower layers, methane is heated and rises again, completing a cycle similar to the water cycle on Earth. When an excess of methane accumulates in the atmosphere, a stable layer forms, preventing heat from reaching the surface. This, in turn, hinders the formation of storms. Neil deGrasse Tyson often talks about how little we know about the universe around us, and Neptune is a striking example of this. Its astonishing storms and methane clouds only emphasize how complex the processes occurring on other planets are. One of the most astonishing discoveries has been the clouds of methane that form unique atmospheric structures. These clouds, made of frozen methane, differ from the clouds we are familiar with on Earth, which primarily consist of water vapor. On Neptune, however, methane freezes in the upper layers of the atmosphere, creating long, thin, cirrus-like formations that are striking in their scale and beauty. These methane clouds, located about 50 kilometers above the main layers of the atmosphere, produce complex light and shadow effects, casting shadows on the layers below. Their length can reach thousands of kilometers, and their width ranges from 50 to 200 kilometers, making them unique even compared to atmospheric phenomena on other gas giant planets. These clouds are not static, they are constantly moving and changing, showcasing the unpredictability and complexity of Neptune's atmosphere. American astronomers have made a significant discovery by revealing a previously unknown connection between the state of Neptune's cloud cover and solar activity cycles. Research has shown that the more active the Sun is, the brighter the clouds on the eighth planet of the solar system become. In 2002, a sharp increase in the number of bright clouds on Neptune was observed, but just 5 years later, the planet dimmed. Neptune brightened again in 2015, but by 2020, its cloud cover reached the lowest level ever recorded, with most clouds disappearing. All these changes in the planet's brightness correlate clearly with the maxima and minima of solar activity. Researchers were quite surprised by this pattern, as Neptune receives 1,000 times less sunlight than Earth. Based on this, they initially suggested that the state of Neptune's cloud cover was related to the seasonal changes that occur every 40 years. However, it turned out that the main factor is the cycles of solar activity. It appears that changes in Neptune's appearance are caused by photochemical processes in the upper layers of the planet's atmosphere, which occur due to an increased flow of ultraviolet radiation during solar storms. There is a 2-year delay between the peak of solar activity and the maximum amount of clouds on Neptune, attributed to the time needed for their formation. What other mysterious features of the atmosphere of this enigmatic planet have been uncovered, and what secrets does it hold? The atmosphere of Neptune is a remarkable blend of chemical elements and unique weather phenomena that make this planet a subject of intense study by scientists. The primary components of Neptune's atmosphere are hydrogen, about 67%, and helium, about 31%. However, it is methane, which comprises less than 2%, that gives the planet its distinctive bluish hue. Methane molecules absorb red and infrared light, leaving only blue and green shades, which we observe in images of Neptune. However, Neptune's atmosphere is not just about its appearance. This planet also astounds with another phenomenon that can captivate even the most skeptical researchers. It rains diamonds on Neptune, a natural wonder that seems to have emerged from the boldest fantasies. Neil deGrasse Tyson often mentions unusual weather phenomena in space, which highlights the importance of studying the atmospheres of distant planets, such as Neptune. As one delves deeper into Neptune's interior, temperature and pressure increase significantly. Results from computer simulations indicate that at a depth of about 7,000 kilometers, the conditions become such that methane begins to break down into its fundamental elements, carbon and hydrogen. The lighter hydrogen rises to Neptune's atmosphere, while carbon, under the influence of the surrounding environment, transforms into diamond crystals that slowly sink toward the planet's core. In addition to its powerful atmospheric phenomena, Neptune boasts a complex system of rings and moons, adding to the intrigue of this distant planet. While Neptune's rings are not as prominent as Saturn's famous rings, they play a crucial role in the dynamics of the planet and its satellite system. The first observations of Neptune's rings were reported by William Lassell, whose drawing of the rings was published on October 10, 1846, in the 589th issue of Astronomische Nachrichten. However, it is likely that this was a case of observational artifact, and the rings were largely forgotten for a long time. The first credible evidence of rings around Neptune was obtained in 1968 by a team of astronomers led by Edward Guinan, who observed stellar occultations by Neptune. However, this went largely unnoticed. Astronomers speculated that the ring might be incomplete, composed of arcs. The reason for this remains unresolved, but it could be due to gravitational interactions with small moons in proximity to the rings. Nonetheless, ground-based observations did not provide clear evidence for the existence of rings. This issue was conclusively addressed by photographs taken in 1989 during the flyby of the Voyager 2 spacecraft, and since then, scientists have actively studied their structure and origin. Neptune has 5 main rings named after prominent astronomers: Gall, Lassell, Leverrier, Arago, and Adams. Each of these rings has its own characteristics. They are composed of dark material, likely a mixture of ice and processed cosmic radiation organic material, and exhibit a reddish hue. The dust content in them ranges from 20% to 70%, with an optical depth of less than 0.1. They are believed to have formed as a result of collisions and subsequent fragmentation of former inner moons. The planet's innermost ring, known as Gall, has a width of about 2,000 kilometers and orbits at a distance of 41,000 to 43,000 kilometers from the planet's surface. This ring is characterized by very low density, with an average optical depth of about 10 circumflex, -4, equivalent to a depth of 0.15 kilometers. The next ring, named Leverrier, has an orbital radius of about 53,200 kilometers and is narrow, with a width of about 113 kilometers. Its normal optical depth is approximately 0.0062 plus 0.0015, corresponding to a depth of 0.7 plus 0.2 kilometers. This ring has a small moon called Despina, which orbits within it at a distance of 52,526 kilometers from Neptune and may play a role in its formation, acting as its shepherd. The Lassell ring is faint, with its material occupying the space between Leverrier and Arago. Its average optical depth is around 10 circumflex, -4, equivalent to a depth of 0.4 kilometers. There is a small peak of brightness at the outer edge, located at 57,200 kilometers from Neptune, measuring 100 kilometers in width. Some scientists refer to this peak as the Arago planetary ring, but many publications do not mention it. The Adams ring is the most studied. It is narrow, slightly eccentric, with a width of about 35 kilometers. Its optical depth is about 0.011 plus 0.003, corresponding to a depth of about 0.4 kilometers. A small moon, Galatea, orbits within Adams at a distance of 61,953 kilometers from the planet, keeping particles within a narrow range of orbits, maintaining a 42-43 resonance with it. The gravitational influence of Galatea creates 42 radial bends, spaced approximately 30 kilometers apart. Particular attention in the Adams ring has been drawn to the so-called arcs. bright arc-shaped segments of the rings that can change shape and size, discovered in 1980. These arcs, named Brotherhood, Equality 1, Equality 2, Liberty, and Bravery, contain relatively dense clusters of particles that are unstable and dynamic. Scientists believe such changes may result from gravitational interactions between the ring and Neptune's nearest moon, Galatea, which holds dust and particles in certain orbits. What do we know about Neptune's moons, their characteristics, and their roles in our system? What mysteries do they hold in their icy depths? As of 2024, there are 16 known moons of Neptune: Triton, Nereid, Naiad, Thalassa, Despina, Galatea, Larissa, Proteus, Ganymede, Neso, Sao, Laomedea, Psamathe, Hippocamp, S2002N5, and S2021N1. According to established planetary nomenclature, Neptune's moons are named after figures from ancient Greek and Roman mythology related to Neptune, Poseidon, or oceans. Among these moons, Despina and Galatea stand out, as their gravitational forces define and maintain the distinct boundaries of Neptune's rings. Despina is a very small moon of Neptune, with a diameter of only 148 kilometers, discovered in 1989 from images taken by the Voyager 2 spacecraft. Upon reviewing the images 20 years later, amateur image processor and philosophy professor Ted Strick noticed something that scientists had previously overlooked. In the images, the shadow of Despina can be seen on the tops of Neptune's blue clouds as it passed across the planet's disk. In ancient Greek mythology, Despina is the daughter of the sea god Poseidon, known as Neptune in ancient Roman mythology. Galatea was also discovered in 1989, thanks to images taken during the Voyager 2 mission. This celestial body is named after a nymph from Greek mythology. Galatea is one of the darkest celestial objects in the solar system and has an irregular shape. It likely formed from debris of previously existing Neptune moons. Galatea orbits below the near-Neptune orbit, causing its orbit to gradually decline due to tidal forces. After several millennia, Galatea may break apart or be engulfed by the planet. What is the largest moon of Neptune, and what do we know about it? Among Neptune's moons, Triton holds a special place as the largest, ranking 7th in size and an unusual satellite of this distant planet, discovered by English astronomer William Lassell on October 10, 1846. It has a diameter of 2,706 kilometers and a mass of 2.14 x 10 circumflex 22 kg, which accounts for 99.5% of the total mass of all currently known moons of Neptune. Triton is one of Neptune's moons that has a retrograde orbit. This means it rotates in the opposite direction to Neptune's rotation, and its orbit is tilted at 67 degrees. In other words, Triton's orbit is almost perpendicular to that of its host planet. As for the surface of the moon, it is mostly uneven, with various elevations, but it also features wide plains. In the southern part of Triton lies a large nitrogen polar ice cap, home to dozens of cryovolcanoes, yet there are not many craters on Triton's surface, indicating that the effects of these impact events may disappear due to internal processes. This suggests the presence of seismic activity. Such phenomena attract the interest of scientists and science popularizers, like Neil deGrasse Tyson, who often discusses the fascinating geological activities on icy moons. Given all this, why is Triton such a peculiar moon? This mysterious moon resembles the distant Pluto more than its neighbors in the solar system. Scientists believe it was born in the cold depths of the Kuiper Belt, at the fringes of our stellar family. However, billions of years ago, Neptune, using its powerful gravitational forces, captured Triton, forever altering its fate. Thus began Triton's life in orbit around the giant planet, far from its native realms. Triton's orbit is yet another of its mysteries. It differs significantly from most moons of planets, leading scientists to two theories. Either the moon simply had bad luck, and its orbit became unusually eccentric by chance, or it collided with another moon of Neptune in the past, drastically altering its path. Equally intriguing is the question of its seismic activity. It is believed that radioactive elements within the moon generate enough heat to sustain its unusual geological activity. This heat transforms frozen water, carbon dioxide, and nitrogen into a sort of slurry, keeping the young surface of the moon in constant motion. Some scientists even speculate that a subsurface ocean of liquid water may be hiding beneath Triton's icy crust. Will there be missions to Neptune and its largest moon in the near future, or will the resolution of its mysteries remain a dream for us? In the coming decade, NASA is preparing one of the most ambitious missions in the history of space exploration, sending a spacecraft to the most distant and mysterious planet in our solar system. In 2031, the mission named Neptune Odyssey will open a new chapter in space exploration. The spacecraft will be launched either by the Space Launch System rocket or SpaceX's Falcon Heavy. By directing the spacecraft not directly to Neptune but utilizing Jupiter's gravity, the travel time can be reduced from 16 to 12 years. The spacecraft is expected to approach Neptune by 2043. The mission's cost will be $3.4 billion. The spacecraft will simultaneously observe both Neptune and its moon Triton. What other surprises and features await us? Will we be able to learn even more about this mysterious planet in the coming decades? Subscribe to the channel and stay tuned for updates to be the first to hear about the most exciting discoveries.